Okay, I'm having a look at our weekly task number 2 for Year 8 Term 4. So we're starting off, as we did in the previous one, is by completing our converting units diagram. So going from kilometres to metres, we are multiplying by 1,000, metres to centimetres, multiplying by 100, and centimetres to millimetres, multiplying by 10. Going back the other way, we are dividing by 10, dividing by 100, and dividing by 1,000. So then we are converting the following. So we've got 190 millimetres, we're going to centimetres. So that means we are going to divide by 10, which means we will get 19 centimetres. We've got 124 centimetres and we want to go to millimetres. So that means we're going to multiply by 10, so we get 1240 millimetres. And then we've got 19.4 metres that we are converting to centimetres. So metres to centimetres, we're going to times by 100. So we're going to get 1940, and that will be our centimetres. Then we've got our question, same as with week 1. So you will see there is an overlap with questions so that you can get lots of practice. Our circumference of a circle. So like I explained in the first video, we can have pi d, or we can have our circumference is equal to 2 pi r, where d is the diameter and r is the radius. Now here we've got a combined shape that we're going to find out the perimeter of. So we know that this little dash here means that this one over here is the same. So we're going to put that 10 metres in. And here we've got half of a circle. Now we know that the diameter of that circle is 8. So what we've got there for our perimeter is we've got our the sum of the sides. We can use as a general rule. And then we can say we've got our 10 plus 8 plus 10 plus, and this is where we have to do the half circle. So we're going to have a half of pi times the diameter. So 10 plus 10 is 20, plus 8 is 28, and we're adding on to that a half times pi times 8. So we can work that out. And we get 12.566 that we're going to add to the 28, and we get 40.566, so we can round that to 40.57, and that is metres for our unit. So then we're going to do our converting our area units like we did for our perimeter units. Here for our area units, we've got those squares there. So if we're going from kilometres to metres squared, we're multiplying by 1,000 squared. And so that means going back the other way, we're dividing by 1,000 squared. We're multiplying by 100 squared, so we're dividing by 100 squared. And in my previous video, you would have seen that I said you could write those out in full and write that as 1,000,000 and 10,000 and 100 there. Or you can leave it with the squared. Here we're converting from 680,000 metres squared to kilometres squared. So that means we're going to divide by 1,000 squared. So we can do 680, 1, 2, 3, divided by, and we've got our 1,000 squared. So we can use that squared button on our calculator, and we get 0.68 kilometres squared. And then 5,000 centimetres squared, we're going to divide by, to go from centimetres squared to metres squared, 100 squared. And we get 0.5 metres squared there. Then we've got our stating the rule. So you'll notice there is a pattern with the questions on each task. So our rule for area of a circle is pi r squared. Our rule for a parallelogram is base times height. Our trapezium is a half outside of a plus b times height. And our rhombus is a half xy. So then we've got an area question here. So we're going to write area of a circle is pi r squared, and we've got our radius there, so we don't have to do any calculations, so we just have to do pi times 11 squared. We don't have to change a denominator to a radius like we sometimes have to. So we've got pi times 11 squared, and we get 380.13, and that will be centimetres squared. And then we've got our trapezium, and there's the parallel lines there on there. So A equals a half outside of a plus b times height. So the 9 and the 15 are our A and B, and the 7 is our height. So we've got a half outside of 9 plus 15, and that's being multiplied by 7. So we're going to go 9 plus 15. We're going to find a half of that, which is 12, and then we're going to multiply that by 7, which gives us 84 meters squared. Okay, going on to the next side of that one, we've got our volume units again, our capacity units. So 1,000 milliliters is the same as 1 litre, 1,000 litres is the same as 1 kiloliter, 1,000 kiloliters is 1 megalitre, 1 centimetre cubed is the same as 1 milliliter, and 1 metre cubed is the same as 1 kiloliter. Here we've got a bit of a trickier shape, and we want to find the surface area and volume of this shape. So when I'm finding out the volume, I need the area of the base times the height. But when I'm talking about the area of the base, I'm talking about the shape that goes through the whole 3D shape, so the 2D shape. So when I'm looking at this 2D shape of a trapezium, going through that whole 3D shape so that I can cut that at any point and get that same face there of that trapezium. So that means that is our base, even though it's not sitting on it, it's still our base. So our volume is area of base times height. So this one, our area of the base is a half outside of A plus B times height, and we're going to multiply the whole thing by the height of the entire shape. So the entire shape is that 10 centimeters, that height. The height of the little trapezium is the 3 centimeters. So we also know that this top of the trapezium is 3 centimeters as well. So we've got a half outside of 3 plus 11, and that's being multiplying by 3, and then the whole thing will be multiplied by 10. So when we do 3 plus 11, we get 14. Half of that is 7 times 3 is 21, and we're timesing that by 10, so we'll get 210, and that will be centimeters cubed. Now when we do our surface area, we're looking at each of the faces. So we've got our 2 trapeziums, so we've got 2 lots of a half outside of A plus B times height, so that gives us the front and the back of the shape. Then we have the 4 rectangles, so we've got the bottom of the shape, and I'm just going to write length times width plus length times width times length plus width, and then I'll go put in the numbers. So for my trapezium part at the front, I've got 2 times a half times 3 plus 11 times 3, and then I'm adding to that my base, the bottom of that shape is 11 times 10. Then we've got the side that's 10 times 5, and we assume that the other side is 10 times 5 as well. And then the top we've got is 3 times 10. So when we've got the 2 times a half, they'll cancel out, so that'll just be 1 times 3 plus 11 times 3. So we get 42 for that one. 11 times 10 is 110. 10 times 5 is 50. 50 plus 30. So when we add that all together, we get 42 plus 110 plus 50 plus 50 plus 30 gives us 282, and that will be centimeters squared. Then we've got our time questions, the same ones we saw in week 1. So we've got 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, 7 days in a week, 52 weeks in a year, and 12 months in a year. Now we're converting our 820 to 24-hour time. So we need to add that 12 to the 8. That gives us 20. We keep the 20 there for the minutes, and then we put a H on the end, so 20 hours. And our congruency rules, same as in week 1. So we've got our codes for the congruent triangles are SSS, SAS, AAS, and RHS. So 3 matching sides, 2 matching sides and a matching angle, 2 matching angles and a matching side, right angle, a hypotenuse matching, and a side matching. And then our 3 rules for our parallel lines are our F rule, our U rule, and our Z rule. You may also have seen that U rule as a C as well. That's our co-interior angles that they add to 180. And then we've got our corresponding angles are the same, and alternate angles are the same. Then we've got looking for the congruent shapes here and stating the reasons for the congruency. So we've got 5, 6, 7, 5, 6, 7, 5, 6, 8. So we know that that one is out. These 2 are the ones that are congruent. and we just need to make sure we label. So, and we've got the 3 matching sides, so that means it's side, side, side. So then we're saying triangle ABC is congruent to triangle, and we need to go in the same order. So if we go A, B, C, so we've got the 5 and the 7 there, which means we would go D, E, F. So we just have to make sure we go round in the right order. Then our last 2 we've got are our Pythagoras theorem questions. So we've got, I need to label our triangle first, so A, B, C, A, B, C. We write our c squared equals a squared plus b squared. And so we've got x squared is equal to 5 squared plus 4 squared. So we get 25 plus 16, which is going to give us 41. So then our x will be the square root of 41. And we get 6.4 as our answer, and that will be 6.4 meters. Then here we're finding the shorter side, so we've got c squared equals a squared plus b squared. Our c squared is 16 plus 9 squared plus x squared. Oh, got them round the wrong way, so I should have gone x squared plus 9 squared. Doesn't actually make a difference to the answer, but just so that I'm using the labels that I chose. 16 squared gives me 256. Then I've got x squared plus 81. So then I'm going to take the 81 from the 256, and I get 175 is x squared. So I'm going to do the square root of that answer, and I get 13.23, and that will be centimeters for my answer there.